Hi guys, I'm Nancy, and I'm going to show you how to solve by completing the square. What is completing the square? It means getting your equation into a neat, perfect square form like this, where you have x plus or minus a number squared equals another number. Why would you want to solve this way? Good question. It's not the best way, usually. It's usually easier or faster to solve by factoring, if possible, or quadratic formula, which you can always use. But probably you've been told that you have to solve by completing the square, so you need to know how to do it. So I will show you the easiest way to solve by completing the square. Unfortunately, you're not given this form straight away. You have to get it. Usually you're given one of these forms. Okay, these are the cases that I'm going to show you. One case is if you have just x squared, positive x squared as your highest term. Another case is if you have a coefficient greater than 1 in front of your x squared, like 2x squared, 3x squared, etc. Third case is if you have a negative coefficient in front of x squared, negative x squared, etc. And in this case, I put here to show you that if you get something like this that doesn't have an x term, a middle term, you can't complete the square. Sometimes people get confused about that. So really, I'm going to show you these three cases. Okay, say you have an equation like this that starts with x squared, positive x squared. The first step, actually for all of these completing the square problems, the first step is to move this constant to the right side. So in this equation, the way you would do that is to add 7 to both sides. So always just move that constant over the right. So what you get is x squared plus 6x equals positive 7. Notice that the sign flipped. That will always happen. If it was negative here, it will be positive there. If it was positive here, it would be negative on the right side. The next step is to add a number to both sides. So you're going to have plus something and plus something. What number do you add? You always get the number by taking the coefficient of x, the coefficient of the middle term, in this case 6, dividing it by 2, and squaring it. And that will be what you'll add to the left and right side. So in this case, it's 6 divided by 2 squared, which simplifies to 3 squared, which equals 9. So we'll be adding 9 to the left side and the right side. So here we fill in plus 9, plus 9. We've added the same thing to both sides. What you do to one side, you must do to the other, so that we don't change the overall value of the equation, so that it's balanced. Okay, so then the next line, that simplifies to x squared plus 6x plus 9. On the right side, we can combine these numbers into 16. 7 plus 9, 16. Why did we do that? Why did we add a number to both sides? The only reason is so that immediately after, we can write the left side as a perfect square. X plus or minus some number squared equals 16 still. The number you write here is always half of what the middle coefficient was. So in this problem, it was 6 over 2, positive 3. If this were negative 6, you would put negative 3. So always in the perfect square side, use half of what the middle coefficient was. So now we have x plus 3 squared equals 16. That's great. You've completed the square. You have something that will be very easy to solve now. And the whole point of doing that was so that you can square root both sides in order to solve. We can literally draw a big square root on the left side and a square root on the right side. Be careful, because when you square root a constant on one side, you actually get two solutions, positive and negative. It's very important, and many people forget this. So try to remember when you square root the side that has the constant, you immediately have two solutions possible, the positive and the negative version. Okay, on the left side, meanwhile, what that does is gets rid of the square. So you just have x plus 3, what was inside the parentheses, equals positive and negative square root of 16. You probably know square root of 16 is 4, since 16 is a perfect square. So then in the next line, you can write x plus 3 equals plus and minus 4. The easiest thing now is to separate this into two solutions. You're going to solve for two different answers. One equation you can write using the positive version, so x plus 3 equals 4. And the other one, you'll use the negative 4 version, x plus 3 equals negative 4. It's very important to separate it out because you will end up with two solutions. So what this gives you using basic algebra, subtracting constants, is x equals 4 minus 3, or positive 1. And on this side, x equals negative 4 minus 3, which is negative 7. So your two solutions, using completing the square, are x equals 1 and x equals negative 7. Okay, say you have an equation that looks like this with 2x squared or 3x squared, etc., where the coefficient of x squared is something bigger than 1. The first step will be the same. You're going to move this constant to the right side. So since it's minus 3 right now, you can add 3 to both sides in order to move it to the right, and you get 2x squared minus 10x equals positive 3. Okay, now what you have to do, because there is a 2 attached to the x squared, or 3, or 4, etc., you have to divide it out from every term in the equation. That will make it easier for you to complete the square. It will make it possible for you to complete the square. So you're dividing every term by 2. That includes the right-hand side. So what you get is just x squared now, which is good, minus 5x, since it was negative 10x over 2. And on the right side, you have 3 divided by 2, which is already in simplest form. It's just 3 halves on the right side. The next step is to add a number to both sides. So you're going to add something here and the same something here. What number do you add? You add this coefficient of x, but divided by 2 and squared. So it's always the coefficient of x over 2, then squared, and that is what you add to the left side and the right side. So in this problem, that's negative 5 divided by 2, all squared, which simplifies to positive 25, because negative 5 times negative 5 is positive 25, over 2 squared on the bottom, which is 4. So you're adding the fraction 25 over 4 to both sides. I gave you one that has a fraction because a lot of times completing the square problems end up a little ugly and have fractions involved. So you'll probably have one like that in your homework. Now you added the same number to both sides because you don't want to change the overall value of the equation. You want to keep it balanced. And what this lets you do immediately after is write the left-hand side as a perfect square, meaning x plus or minus a number squared. That's the whole point of adding that number, is so that on the left side, you can immediately write x and some number here squared. What number do you write? It's this coefficient over 2. So it's negative 5 over 2. And since it's negative, instead of addition, it's subtraction, minus 5 over 2 squared equals the right-hand constant. Since this is an uglier example, it has some fractions involved. You'll have to get a common denominator in order to combine them, or plug them into your calculator if you're allowed to use your calculator. A lot of calculators are very good at adding and simplifying fractions. What you have to do is get a common denominator, which would be 4 in this case. So you have 25 over 4, and you have 3 halves, which can also be written as 6 over 4. If you multiply the bottom by 2 to get 4, you also have to multiply the top by 2 to get 6. So in the next line, you can rewrite this as x minus 5 halves squared equals, and combine the fractions. Since the denominators are the same, you keep it as 4. And the numerators you add. So 6 plus 25 gives you 31. Great, so you've completed the square, and this is in a form that will be very easy for you to solve. What you want to do is square root both sides. So on the left side, it's a big square root. On the right side, you do a square root of the constant, but you immediately get positive and negative versions. So remember, when you square root this side that is just a number, you have to put plus and minus. If you don't, you'll only have half the solutions. You only have 1 instead of 2 solutions in the end. So it's very important. People forget it all the time. But you want to square root both sides. What that leaves you on the left is just x minus 5 halves, because your square root undid the square, and you just have what's left inside the parentheses. So x minus 5 halves equals plus and minus square root of 31 over square root of 4, which you can just write as 2. Then you'll want to use some simple algebra to move this constant over so you have x alone. And your 2 solutions will be x equals 5 halves plus or minus root 31 over 2. You can actually combine this into one fraction, which most people would consider simpler. So you may want to do that. And your final answer would look like this. X equals 5 plus or minus square root 31 as your numerator, all over 2 as your denominator. So these are your 2 solutions you got from completing the square. It may not look like it, but this is 2 solutions because you have 2 versions. You have 5 plus square root of 31 all over 2, and you have 5 minus square root of 31 all over 2. So those are your answers. Okay, say you have an equation that looks like this, that starts with a negative x squared, or negative 2x squared, where the coefficient of x squared is a negative number. Your first step will still always be to move the constant over to the right-hand side. So in the next line you would have negative x squared minus 6x equals negative 7. Notice the sign changed. And then you don't want the negative in front of the x squared before you complete the square. So you actually will divide every term by a negative 1 to get rid of it. Since there actually is a negative 1 here, you don't see the 1, but you can divide every term by negative 1, even the right-hand side. And what that does is it flips the sign of every term. So instead of negative x squared, you'll have positive x squared, which you want, positive 6x, and on the right side, positive 7. And then your steps from there will be the same as in problem 1 and 2. Adding a number to both sides that you get from dividing this number by 2 and squaring it. So you would add 9 to both sides. 6 over 2 squared, 9 to both sides. Writing it as a perfect square, solving by square rooting both sides. From then on, it would be the same. So notice this is a lot like case number 2, example number 2, where you divide out anything that was in front of x squared. Okay, things that tend to trip people up about completing a square. The biggest thing is forgetting to put plus and minus in the solutions. So if you get to the point where you have an equation that looks like this, when you square root both sides to solve, a lot of people forget to put plus and minus here on the constant side and just write the roots. Lots of people forget that. You don't want to miss the other solution. There are 2 solutions, and if you don't put the plus and minus, you're only getting the positive solution. So remember the plus and minus. A lot of people forget that. So you just have x minus 4 equals plus and minus 5 in this case, and you would keep solving from there. So that's the biggest thing people forget when completing the square. Another thing that trips people up is sometimes they think you can complete the square if there's no x term. For instance, if you had 3x squared minus 121 equals 0, if that was your equation, you can't complete the square because you have no x term, such as 3x squared plus 10x minus 121. If there's no x term there, you have no coefficient to use when adding a number both sides. So you can't complete the square if it looks like that. You'll have to use another method, so factoring, quadratic formula, something like that. So I hope that helped you understand how to solve by completing the square. Completing the square is fascinating. No, it's okay. You don't have to like it, but you can like my video. So if this helped you, please click like below.